solving one-step equations either by adding or subtracting. So some general things. Now to make sure you know what we mean when we say solve an equation, it means get the positive variable by itself with no coefficient on one side. And whatever side the variable's on, the solution is on the other side. So just to make sure you understand what I'm emphasizing and pointing out here, I could have an answer 3 equals x or x equals 3. Those are both good. Doesn't matter which side the variable's on. But if I had negative x equals 3, I've not finished solving the problem because there's a negative variable, not a positive variable. I'd need to get rid of that negative. Or if I had something like 2y equals 6, I'm not finished there either because I don't have the y by itself. There's still a 2 attached to it. The variable has to be entirely by itself and have no coefficient or negative sign with it. To get the variable by itself, we'll have to do the opposite, or another math word for it is the inverse operation of the operation that is happening to the variable. In other words, if the variable is having something added to it, we need to do the opposite and subtract from it. If the variable is having something subtracted from it, we need to do the opposite and add to it. Okay, so on number 1, for example, x is having something being subtracted from it, x minus 9. So we need to get the x by itself. Right now there's a minus 9 attached to it that we need to remove. So we're going to have to add 9 to it, because the whole idea is that this is just like a negative 9. Minus 9 can be treated just like a negative 9. Negative 9 plus 9 is 0, so that just cancels out. Now there's no longer a 9 attached to the x. 12 plus 9 is 21. And if it helps, you can check this answer. You can say, all right, let's go back to the beginning. It said x, the number I didn't know, minus 9 equal 12. So I can test that and say, all right, 21 minus 9, and that does in fact equal 12. So that shows we found the right answer. Number 2, we do have the variable on the right side this time, but that's fine. Just like I pointed out up here, it doesn't matter if the variable's on the right or the left. The point is it has to be by itself, no matter which side it's on. So right now, what's with the y is a plus 10. That's addition. So we need to do the opposite and subtract 10. Because if we subtract 10, 10 minus 10 is 0. And whatever we do to one side, we have to also do it to the other. Negative 9 minus 10 is negative 19. And you could check it back here. You could say, all right, let's test it. Negative 19 plus 10, that is equal to negative 9. And that verifies that it's the same as what we have here. Number 3, I also made a point to show you that it not only does it not matter whether the variable is on the left of the equal sign or the right of the equal sign, as we saw in number 1 and number 2, it also doesn't matter if, looking at just one side, if the variable is first or second. Doesn't change the problem. Here, we notice it's a positive 13. So if we want to get rid of a positive 13, we need to subtract 13. 13 minus 13 is 0, so that cancels out. 62 minus 13 is 49. And again, you could go back and check. 13 plus 49 is 62. So I want to word this one differently to maybe help you understand why we have to do the opposite. So imagine someone's just playing a trick on you or trying to trick you and saying, okay, I'm thinking of a number. They say, okay, if you subtract 12 from my number, you're going to get negative 3. So we have to work backwards because they knew what number it was to start with. So they knew this number, and then they subtracted 12 from it, and the result was negative 3. So if we want to figure out where they started, we have to work backwards. They started from the question, the variable. Then they subtracted 12 and got negative 3. We start from the negative 3 and work backwards to find out where they started. So they subtracted 12 to get negative 3. So we need to do the opposite and add 12 to find out where they started. So negative 3 plus 12 is 9. So they thought of 9, and they said 9 minus 12 and got negative 3. So we reversed what they did, and we added 12 to negative 3 and got what they started with, 9. Okay, number 5. Anytime you see minus and negative in a problem, the first thing you should do is change it to plus a positive. Because really we need to see this and understand it as a positive 12 or a plus 12. So to get the x by itself, we'll actually need to subtract 12 from both sides. 4 minus 12 is negative 8. So we get that x is equal to negative 8. On 6, let's talk like we did before, where it's kind of like, okay, what if someone's trying to trick you or make you figure something out? They say, all right, I started with a 4, and then I added to that 4 a number I'm not going to tell you, and my result was 15. So they started with a 4, and they added a number to it that they were not telling you, and the result was 15. So we can work backwards, because they added their mystery number in 4 to get 15. So we can subtract 4 from 15 and find out that their mystery number was 11. Because 4 plus 11 equals 15. Okay, number 7. We have a variable and we are subtracting 7. So we do the opposite of subtracting 7. We add 7 to both sides. Because whatever you do to one side, you have to do the other. Otherwise, these wouldn't stay equal. An equation means both sides are equal to each other. So that's true when we start, but if we change one side, we have to change the other side the same amount, otherwise they won't be equal anymore. Negative 5 plus 7 is 2. We can go back and check, okay, 2 minus 7 does equal negative 5, so that's good. Okay, number 8. C is having 10 added to it, so we need to do the opposite of addition and subtract 10 from both sides. 9 minus 10 is negative 1. The 10s cancel out, so the C is now by itself. I'd encourage you to pause the video at this point and see if you can do these 4 on your own. There's nothing particularly different about these in the back. I'm just trying to make sure you have plenty of practice. So if you are able, I would pause the video, try these 4, then press play and see how you did. Okay, now here's one thing that can be tricky. You see a plus sign here. So understandably you might think, oh, I need to subtract to get rid of that 1. But we don't look at the sign or the operation in front of the variable. The variable needs to be positive, so that actually means that's right where it should be. It's positive z. What we need to look at is the sign or the operation in front of the number, because the number is what has to move. And this 1 is a negative 1. So to move it, we have to do the opposite of that negative sign in front of the 1 and add 1 to both sides. Because the whole goal is to cancel this out, to get rid of it, so the z is by itself. Negative 1 plus 1 is 0, so they do cancel out. And 13 plus 1 is 14. Negative 1 plus 14 is 13. 10, just like one we had on the front, as soon as you see minus a negative, you need to change it to plus a positive, because that allows you to see clearly this really is a positive 8 that's being added, so we do the opposite and we subtract. So we get a equals negative 3 minus 8 is negative 11. Okay, 11 is another one where you might be like, wait a minute, I see a plus and a negative. Which one do I do? Okay, just like up here I told you, look at what's in front of the number you need to move It's the same idea here. We need to look at the 9 that needs to move because our goal is to get x by itself. What's directly in front of the 9 is a negative. So to get rid of that negative 9, we need to add 9 to both sides. Because now we have x plus 0, which is x, negative 4 plus 9, which is 5. And 5 plus negative 9 is negative 4. Okay, last one, we are adding 11 to the x, so we need to do the opposite and subtract 11 from both sides. 11 minus 11 is 0, leaving just the x. Negative 6 minus 11 is negative 17. So to solve an equation, we always need to do the opposite of what's being done to the variable. The variable had 11 added to it to give us negative 6. So we needed to subtract 11 from the negative 6 to get the variable.